and thank you for your availability.
Thank you very much, and good morning to you. I think you're Anatoly. Am I correct? Anatoly. Am I correcting your name correctly?
Yes, Anatoly.
It's correct. Anatoly. Okay.
Yeah.
Okay. Okay. Next to me is
and so one more colleague will be joining, but a bit later because Anna is finishing the meeting. She had with Raim, but we start and like in few minutes she will join. And one more update for Anatoly. At 11, he would need also to leave like for 10 or 15 minutes to make just one quick phone call and he'll get back. So just for you to know that Anatoly will disappear and appear again, but like later on and for a few minutes. So this is like organizational stuff. And once more, thank you for your availability, because as you know, we are pushing for the training because it's really important for us to improve our daily communication with clients.
Okay, thank you. And we are sorry that we could not actually arrange for the meeting last week because of the problems we had with respect to the internet connection. But it seems this is okay today. Next to me is Mr. Ranjbarian, who has actually prepared that topics for the second session of the meeting, the same as the first one. And I hope that you have gone through that presentation for the second meeting, and we can of course now start the page slide by slide and also receive your questions and queries to be able to answer.
Sure, thank you.
Please. Later, I will also send the phone number for Mr. Ranjbarian, so that in case of any question, you can also, contact him. Sayed, are you ready? Is everybody there?
Yeah. Hi. Good morning. Good morning. I am sorry. Actually, I listen you. Yeah, and I'm ready to participate for this meeting as well.
All right. Shall we go through? Shall we start it?
Yes, please.
All right. Sayed, we sent you the presentation for the second session last week, and I don't know if you have gone through that or not. We are going actually to discuss a little bit about the theory of compression in general. All right.
Right. Yeah, we got your email along with the presentation PowerPoint, and yes, we was reviewed it, and meanwhile, like you will going to explain and teach us, so maybe we will be going to ask some kind of a question in meanwhile.
All right. Okay. We started with the basic information, very basic information that you may need for selecting selecting a machine, a gas processing machine, which could be a blower, fan, or compressor. Now I request Mr. Ranjbarian to go through that and start, explaining about the presentation slide by slide.
That's great.
Okay, let's start that. We want to speak about, discuss about the main parameter for selecting a tool machinery. It's so important you have a good understanding about the basic parameter because you can evaluating the turbo machinery, you can select the right equipment and other things. Okay, let's start. The main parameter of the selecting turbo machinery. The main parameter are so important to select an equipment truly. Right choice has a great impact on capital and maintenance costs, reliability, serviceability, and other. And describe the behavior of the turbo machinery. It's so important because cost is the main parameter and we want to reduce that as possible. Type of application is the first parameter we discuss about it. It's so important to know what type of the equipment is. Is it a driver to power generator or it's a driven such as a compressor to absorb power and increase the gas pressure? Application of the turbo machinery is the first parameter you should consider that because many times you want to select a true driver, for example, gas turbine, for example, electrical motor, or other turbines. Or in some cases, you want to select an equipment for compression. Which type of the equipment is good for you? For example, compressor, blower, or fan. Okay, type of the media or process flow is a second parameter and it's so important. Depends on the media, you can select right category. For example, when you need a device for a water transporting in the plant, in the wastewater facility and other, you must select the pumps. If you have a steam or rotating a generator, you must use a steam turbine. For a compressor and blower, we're working with the gas and with the gases flow. It's so important to consider amount of the water in your process flow. For example, if you have a higher level of the water particle, you cannot choose a centrifugal compressor for compressing a gas. And you must use a liquid ring compressor. It's so important. For example, if the many particles, solid particle in your gas, you must use another equipment, for example, reciprocating compressor, because solid particle can damage your impeller, your blade of the centrifugal compressor. Do you have any question on this section?
Yes, please carry on.
Okay, condition of the fluid. Of the fluid is an important key to have right equipment and have major impact on the type of machinery. For example, you must select an equipment to compress natural gas. In this situation, you can select a compressor, a blower, or a fan, but it depends on the amount of the pressure ratio and capacity or flow. We can describe condition of the flow with the flow parameter. Pressure. Pressure is the name given to the force exerted by fluid particles to the wall of the container. Pressure can be expressed in the two methods, absolute pressure and gauge pressure. It's so important. We're working with different pressure. For example, static pressure, dynamic pressure, total pressure, and other. We don't want to speak about this parameter because it's soon, and after that we will discuss about it completely. Absolute pressure. The absolute pressure is the pressure measured above a perfect vacuum. Gauge pressure. The gauge pressure is that pressure which is measured directly with exciting barometric pressure at zero base reference. It's so important because when you have inquiry at the first step, you must check the pressure and unit of this. And in many times for select selection for size gauge pressure from the one unit to other unit.
Okay, Sayed, I want to actually explain further about these pressures, because in many inquiries that we have been receiving from your side, we noticed that I would say the type of pressure, whether to be gauge or absolute, had not been specified, had not been defined. And so if you go to some of the correspondences that we had with Anna, with Svetlana, with yourself, and you noticed as one of the first questions that I had raised was about the pressure given in the MR or data sheet in the inquiry package, whether it was gauge or absolute. Okay. To understand the difference between gauge and pressure and absolute is not really difficult, is a simple issue. When you measure the pressure inside the vessel or pipe or equipment or in a process and compare it to the pressure at that site, at that moment, that pressure measured in the vessel, in the system, is called gauge pressure. All right? Gauge, I would, we could also call it relative pressure, because it measures the pressure above the environment, above the atmosphere. All right? And
I have a question, Mr. Sadri.
please.
A barometric is like an utility to measure the pressure?
Barometric pressure is equal, has exactly the same meaning at atmospheric pressure, or I would say the pressure at site. Okay, before continuing with gauge, I would actually explain further about the barometric or gauge. You live in a place very close to the sea, I believe, to the ocean. Am I correct?
Yes, correct.
Okay. Over there, you can make a note. You can make a note of this figure that I'm gonna give to you in a second. At your place, which is very close to the ocean, barometric pressure, which is the atmospheric pressure, or I would call it, it is pressure at the site. I think, okay, let's assume that your office is a site. The pressure of air over there is something very close to 1.011 or 1.012, something around that. It depends on the temperature. If you're just at the seashore, okay, and then the temperature over there is 0 degrees centigrade, then exact pressure at that moment at the seashore is 1.013 bar. Okay, and after we put 1.013 bar, we put an A at the end. A, it is abbreviation for absolute. You know, pressure at site, barometric pressure or atmospheric pressures, or always expressed in absolute. Always in absolute, no matter where you are. The amount, the figure, of course, changes. If from the seashore you go to the mountains at the same temperatures, just suppose that you go to Alps, okay, to the elevation of I don't know 3,000 meters above sea level, at the same temperatures, which 0 degrees centigrade, the atmospheric over there will not be 1.013 bar absolute. It will be very low, probably, I don't know. It is probably about 0.78 bar absolute. This is atmospheric pressure, again, barometric pressure, or the pressure at site, which is dependent on 2 items, 2 parameters. 1, temperature at the site, 2, elevation from sea level. Is it correct? Is it clear so far?
Yes, yes.
Good. Now, okay. Now that you're aware of the pressure at the site or barometric pressure. Now, suppose that you have a container, closed container, fully closed container. You have a cylinder, whatever you may imagine, all right? And you put a pressure gauge on it. When you have not the pressure gauge on it, the pressure gauge in your hand reads and measures the pressure of the ambient, of the barometric pressure. And it is always 0, no matter where you go. No matter you go, it always shows 0. You have a pressure gauge. We may call it pressure indicator, pressure gauge. This is the device which measures the pressure. You have it in hand. Whenever you go, it shows 0. Whether you're at the seashore or in the mountains, in the desert, or I don't know, somewhere in Himalaya, in Everest, it always shows 0 because it is relative. It shows relative pressure to the atmosphere. Since it is in your hand and not installed on any equipment, on any device, on any container, any vessel, it is just in your hand. And it feels the pressure from the atmosphere and compares to the pressure which is against from the atmosphere. The difference is 0 always. So now you mount this pressure gauge on on a vessel, on a container, on a cylinder, and it reads 2.5. This is now gauge pressure. It is telling you that the pressure inside that vessel is 2.5 above the atmosphere pressure around the container. This is called gauge, relative. All right.
Okay. Yeah.
Now you wanna you wanna calculate the so-called absolute pressure. The absolute pressure is the sum of gauge pressure plus the barometric pressure, and this is something which changes from one place to the other place. Even for the same equipment. Just let me give you an example. You have a you have a cylinder of oxygen. You have seen oxygen cylinders in hospitals and in buildings. Okay, oxygen cylinders, you know, under pressure of 200 bar normally. 200 bar is a huge amount of pressure. Now, you're at the seashore. You measure the pressure on the cylinder, and you read it 200 bar. Someone asks you how much is the absolute pressure. Okay, then you add 200 bar to the atmospheric pressure at the seashore, which is 1.013. It's gonna be 201.013, like that. Now, you take the same cylinder to the mountains, 500 kilometers away from your town, 2,000 kilometers away. Over there, and of course at the same temperature. We are talking all the time about the same temperature, whether at sea coast or in the mountains. Over there, the pressure inside the cylinder is still 200 bar. But this is 200 bar gauge. How much is the absolute? Should the amount of the pressure at the site in the mountains should be added. Over there, the pressure is not 1.013. It is much lower. Therefore, absolute pressure over there is less than the absolute pressure at the, let's say, seashore for the same device, for the same containers, same machine, whatever you call it. That is why whenever we receive data sheet inquiries and something from you, the first question, if not mentioned, the first question that you should always ask is, what are the site conditions, dear client? Where are you located? Where is your location? Are you as 1,500 meters above sea level and 42 degrees centigrade? Or are you at sea coast and minus 3 degrees centigrade? Where are you? What is your location? We have to know your location, because that location actually specifies the pressures, we call it absolute pressures, that we need for the calculation, and you will get familiar with that in a moment, all right? In addition to the site condition, we must know the, of course, if they give us the site conditions, everything is clear. Then we should know the pressure that they are giving. They want the device to produce, I don't know, 7.5 bar. Okay, the question is 7.5, I'm sorry, 7.5 bar what? Gauge or absolute? If they say gauge, all right, we add the atmospheric pressure to it. If they say it is absolute, okay, that is fine. We don't add anything, and we proceed with that figure that had given for the absolute pressure. So again, this is important for any calculation, for any machine. Believe me, even if you want to design or even purchase a pump, centrifugal pump for water, for any liquid, although the behavior of the liquid is quite different from that of gas, but still they must give you they give in the data sheet for the pump, they give you pressure at the suction. All right. Is it gauge or is it absolute? This is first question. Number two, where are you? What is the site conditions? How much altitude shall I consider? What temperature shall I consider? These affect. Where do they affect? At least it will affect selection of the motor, electric motor for that equipment. So I don't know if I was clear enough, but you see, the formula is given on slide number 4. You know, it reads P gauge is equal to P absolute minus P atmosphere. I like to put it the other way around, and I once wrote it to an email to Svetlana. I like to write it this way: P absolute is equal to P gauge plus P atmosphere. Actually, I have moved the P atmosphere from the right side of the equation to the left side. I think this is going to be more, let's say, expressive, I think, and more understandable, I think.
Yeah, it is. Thank you.
Now, Mr. Rajbarian is writing something on the board. I don't know if you can. Okay.
We cannot see your webcam.
Oh, you cannot see the. Okay.
In case you will be close the screen, the sharing screen, we will be able to see your webcam. Yeah.
Yes. All right. Okay.
Okay. With this equation, you can convert a gauge pressure to absolute and reverse. It's so important to have a good understanding about this pressure and atmospheric pressure. At the next section, we discuss about the atmospheric pressure and how we can calculate it. Okay, gauge pressure can be described in the same units such as absolute pressure, but use a G suffix, for example, bar G, Pascal G, and other. It's so important in inquiry and data sheet to clarify it, to use for calculation, design, and other things. Sometimes P with suffix A is used to show absolute pressure, and P with G suffix is used to show gauge pressure. In many cases, atmospheric pressure is called also barometric pressure, that Mr. Sadi described it completely. Okay, I have a question. Any one of you can describe for me total pressure?
Absolutely.
In generally, the definition is says that in a mixture of ideal gases, the total pressure refer to the sum of each gas's partial pressure.
That is correct.
Yes,
That's the correct definition. Yes, that is correct. Yeah.
Thank you.
Okay, in the compressor, blower, and fan, we have two important pressure: suction, intake or inlet pressure, and the discharge of the pressure. In the inquiries, we must have these values. Suction pressure is a fluid pressure at the compressor entrance or blower or fan. Discharge pressure is a fluid pressure at the compressor, blower, or fan outlet. In turbo machinery, two concepts are used widely: pressure ratio and differential pressure. This two parameter is so important to selecting and compressor, blower, and we will discuss about it at the next session. Okay, differential pressure. The differential pressure is the difference between any two pressure measured with respect to common reference. For example, differential pressure between two absolute pressure, and it's expressed in pressure unit without any suffix. We can show it with the bar, Pascal, and other units, and show with the symbol delta P. Delta P is equal to P2 minus P1. P2 and P1 must be either absolute or gauge. One should not be gauge and the other absolute. It's so important. Use it only in the absolute concept. Okay, for pressure ratio, okay, we can define delta P in the compressor, blower, and fan, pumps, turbines, and other equipment with these definitions. Delta P is equal to discharge pressure minus suction pressure. Pressure ratio. Pressure ratio is the ratio of the absolute discharge pressure to the absolute inlet pressure. Pressure ratio is a dimensionless value and show with PR. It's so important, it's dimensionless value. Okay, pressure ratio. Pressure ratio is equal to discharge pressure
To suction pressure.
divided to suction pressure.
And there is this important point again here. When we calculate pressure ratio, both discharge pressure and suction pressure must be absolute. This is important. If you divide discharge pressure by suction pressure in gauge, we get a wrong pressure ratio, and that cannot be relied on. All right. So this is very important to make sure whenever you want to calculate pressure ratio, both discharge and suction pressure must be in absolute. But when you want to calculate differential pressure, if you go 2 lines above, then both discharge or suction, both at the same time, could be either absolute or gauge. Is it clear?
Yeah, it's clear. Yeah,
Okay,
should be
good.
both are same.
Yeah, for delta P. For delta P should be the same. For pressure ratio, both must be absolute amount and not gauge amount. All right. Shall we go on?
Yes, please. Thank you. Keep going.
Okay, barometric pressure or atmospheric pressure. Barometric pressure is a force per unit area exerted by atmosphere and changed with elevation from the sea level and air temperature. Barometric pressure can be calculated with below formula. It's a so important formula. You can calculate the barometric pressure with this, but it's not necessary because many sites in the internet, in the web, you can find to calculate the barometric pressure easily. I will show to you. Okay, in this formula, P with suffix 0 is the sea level pressure, and it's equal to 101.325 kilopascal absolute, or 1013.25 millibar absolute. G is the acceleration due to gravity, and it's equal to 9.80665 meter per square of the second. M is the molar mass of the air, and it's equal to 0.0289644 kilogram per mole. T is the temperature at the sea level and expressed in the Kelvin. We will discuss about it. R is the universal gas constant, and it's equal to 8.31432 Newton meter per mole Kelvin. Is necessary to use this formula? No. For example, this site can calculate for you barometric pressure easily. I will show to you.
You never actually need to use that formula to have the atmospheric pressure at different sites, because there are so many tables, graphs, and even calculators that you can easily actually calculate the pressure, air pressure, or what I would say atmospheric pressure or barometric pressure. Those are the same. You can calculate them easily, you know, for different sites, different places.
That's correct.
Yeah, can you see the screen now?
The only presentation screen we can see.
Oh, okay, okay, already, okay. Let me.
Now, can you
Yes,
see it?
yes,
okay.
exactly. We can see.
Yeah.
Okay,
Yeah.
at the left side in the yellow box, you can calculate altitude with air pressure, and at the right side in the blue box, you can calculate air pressure. For example, you must select a compressor for a city. The elevation of the city from the sea level is 1,300. Okay,
Meters.
meters. So easily you can calculate the air pressure for this city in the many units, for example, Pascal, PSI, and atmosphere. Or for example, you must select the blower for a city. It must install in the city with elevation of the 1,100 meters from the sea level. Okay, you can calculation air pressure so easily. I ask to you in any inquiry, you check the elevation from the sea level and barometric pressure together with the site, because in many cases clients make a fault and the data is wrong, and it's not so good, because when we want to design or select the equipment, it's so important to have a correct data. انا میخوام این مسئله رو براشون حل کنم، میخوام بهشون بگم یه رستی بکنید تو این مسئله براشون بنویسن و
میخواد تو رست انجام بدن
آره
یا نه؟
یه رستی انجام بدن، بعد ما این مسئله سریع براشون
بعد شما شروع
آره
کنید.
الان یه رستی بریم که من مسئله رو بتونم بنویسم بعد براشون.
Okay, Mr. Ransbarian is gonna actually write a question on the board, and if you actually you know, you would have a few minutes off, and you would come back. It takes few minutes for him actually to write the case on the board, and then he will request you to solve the problem. Okay, he's gonna write it, so we could be back in 5 minutes, I think.
Yeah, fine, no worries. You may
Okay.
have a time also for the refreshment in case.
Okay, we can. Okay, we have actually moved the camera so that you can see the board, you know, easily.
Thank you.
Okay.
Okay.
So for any question, again, please ask whatever you may have, you know, any queries or any, let's say, question.
Well, it is really very clear as of now, the presentation, the explanation, and it's really great. In case definitely any kind of a question will come up, we will be going to raise and ask you.
Okay, great.
Agreed.
میارمش اینجا نه میتونه بکنه. We have essential آره. Sayed, who are now the ladies and gentlemen attending this meeting? I think I have missed some of them.
Everyone except Anna. Basically, she is in the meeting, another meeting.
Oh, okay,
And
okay.
as you know very well that Dr. Kotai is busy with Mr. Sajjad already
Okay,
here.
okay, okay.
So Svetlana is here, Anatoly is here, Claudia is here, myself. So yeah, and of
All right.
course this presentation is a recording and could be able to helpful for any of the person in later stage for to read, review, and see the presentation.
Right. Okay, great. برای استش کامپرسور اشکال نداره. پنجره رو متوجه مثلا دیگه ایجاد کرده. یه اینکه واقعا باید بریم که سراغ که سایتش هم ببینیم کجا هستش. میخوایم بریم
شارژ میگم
12 هست.
فدریشن از سطح
خب شما نباید بکنی که اینو باید ولی باید بگی که ارتفاعش چقدر هست. بذار بشه
یکی که دیتاشن چقدره
آره. من 6 نفر هستم فقط افلاتانا همه هستن و خود من از ادامه سال از اون برده دارم چون داریم فارسی چیز میکنیم خب من هم که ممکنه دید میگم آره خب حالا باید و در جهارت هم برداشتیم آها The question Mr. Ranperian is writing on the board is about the calculation of differential pressure and pressure ratio for a process in which a centrifugal compressor is used. And he's also giving some data for the site, for the place that this device is going to be installed. So I'm not going to cheat, so I wouldn't talk much more. So
we are still love to hear from you.
Okay, no, I'm just giving very general information that he will give you in a moment. Then you need to tell us about the differential pressure and the pressure ratio. You see, let me explain again. You know, when you see a data sheet for any equipment, any rotating equipment, whether it's a pump, is a blower, it is fan, and it is a compressor, even for reciprocating compressor, the very major data is this amount of suction pressure as well as the pressure they need for their process. That is called discharge pressures. That is the pressure which should be generated by the machine. It would be very low, let's say 25 millibar, which can be done by a ventilator, or it could be 25 bar. I mean, 1,000 times of that, 1,000 times of that, which could be generated by a reciprocating compressor and even by a centrifugal compressor. So I want to tell you, the amount of discharge pressure that the client specifies is the figure for the discharge pressure of the machine that they need. They need what for? They need for their process. Whatever the process is or will be, they tell you what pressure they need. Of course, they calculate the amount of pressure loss from the device to their plant. It could be, let's say, 50 meters or sometimes 2,000 meters, right? 2 kilometers. That is in their own pocket. That is in their responsibility. They ask for the pressure at the battery limit of the machine that you're coating or you're selling. And the word battery limit actually is something that you should and we should pay attention to on the PNID that you receive from the client. It tells you where the boundaries are, the boundaries of your equipment. That is important. PNID, they may show some items, some vessels, some devices, some instruments which are not in the scope of vendor simply because they are out of boundary. This is called battery limit. All right. So, and battery limit is shown by cut lines, okay, and sometimes lines and dots around and it is on PNID. PNID is the best place actually to find it, or PFD. PFD stands for a process flow diagram, which unfortunately many clients do not give it, and that is could be very good document for the vendor to understand what the scope is and what the process is. I would recommend to you from now on. I know this is going to be difficult. I know it is difficult if you have not practiced it before, but my own practice tells me that if you try to understand the process, the life will be much easier for you. Believe me. I know this is not very easy to do at the first stance, at the first moment. No. But if it starts with very simple processes and try to understand the process. What do I mean by process? Always ask yourself what this machine that I'm going to offer is supposed to do. What is his job? What is the requirement for this machine? How this machine is going to be used? How is it utilized by the client? In what process? What is that going to develop or to generate, to give out? This is called process. If you understand the process, it would be very more understandable to you the device that you want to design and select and hopefully sell. So I think now we are going to the problem raised by Mr. Ranjabrian in a moment. Let me move the
بعد من استفاده کنم دست بگیرش میفته نمیتونم ببینم یعنی باید میره جلوتر اگه بشه بیایم جلو چون اینجا نور میفته.
خب شما ببینید که اسکرین رو میتونید چیز کنید. Can you see the whiteboard now?
ولی واضح نمیشه.
Yes, we can see, but
Can
in
you read
case
this
you
by
can,
you?
you're not seen.
Can you see the whiteboard?
Can you make this presentation close so we can see this your board with the large screen, because the screen is a little smaller, which is not visible to us.
All right. How is it now?
Yeah, it's better now. Better.
Is it okay now? Is it readable, Sayed?
No, it's not readable. The point what I am trying to say, if in case we can close the presentation we are sharing, maybe your screen will be appear on the main screen, because now it is on the right side with the small screen, which we cannot read it. I'm not sure if I can convey you my question. Yeah, if you can stop, yeah.
Okay.
Yeah, it's much
Yes.
better.
Thank you. Now we can see it. Thank you.
Okay. Well, that's okay. We have a centrifugal compressor here with the suction pressure 5 bar with suffix G. And the discharge pressure is 20 bar G. Okay. Well, I asked to you to calculate the suction pressure and discharge pressure in the absolute term, and after that calculate pressure ratio, differential pressure. This compressor will be installed on the city with elevation from the sea level 1150 meter.
اینجا وارونه نشون میده تو این تصویر رو گفتم آینه شده الان چرا اینطوری میشه نباید اینطوری الان وارونه نشون میده
برعکس خب چون دود نبوده
نه تصویری که بعد نمی‌کردم من بس کنید این سمت راستش رفته سمت چپ
چون روی دیگه
خب حالا میخواد
حل کنن دیگه
آره ولی خب میخواد بره ارتفاع رو بده بدادم باید برش سایت Is the problem clear to you?
We can see it, not very clear, but we can see it.
Suction pressure is a 5 bar G. Okay. Discharge pressure
is 12. 1, 2 pressure.
Suction pressure is
5 bar G. G means gauge, all right?
Gauge.
G
And
means
discharge
gauge.
pressure?
12, 1, 2, 12 pressure, 12 bar G.
So what is, if we need to drive now?
Okay, and you need one more information. The elevation, the site elevation, and the altitude at the site is 1,150 meters.
1150, right?
Yeah, exactly, 1150 meters above. The first thing actually you need to know or to reach is the atmospheric pressure at the site.
Por isso nós vamos preparar o parágrafo e vamos indicar todos os momentos desse parágrafo para analisar. Acho melhor.
Can you please repeat? We have one section pressure, which is 5 bar G. Discharge pressure, we have 12 bar G. And we have a site altitude height, which is 1150 meter. And what the other things needs to understand and adopt in order to
The discharge
calculate?
pressure is 20 bar G.
It's a 12 bar or 20?
20.
No, 12.
Yeah, 12 bar G.
Yes. Well, actually, yeah, 12, 1, 2.
And what we need to drive, what we need to get the result?
Pressure
should we
ratio,
calculate?
differential pressure, suction pressure, and discharge pressure in absolute term, and atmospheric pressure.
Round. R-U-N-D. Or R-O-U-N-D.
So the differential pressure is 7 bar G.
Yes.
Correct, but thank you for actually making a small mistake, because if you hadn't made this mistake, I would have forgotten actually to mention this typical type of mistake. Correct. Of course, the differential pressure is 7 bar, but we never for differential pressure say something bar G or A, never. It is simply 7 bar.
Okay,
Finish.
it will be simply, there will be no other, okay, unit
No,
will be
no, no,
involved.
no suffix, no suffix after, when we say differential, both sides are either gauge or absolute. Am I correct? You know,
Okay.
differential means A minus B,
Asked на прошлом суммаре.
P2 minus P1, all right?
Okay.
P2 and P1 are both either in gauge or absolute. If they are gauge, gauge from this side and gauge from that side go away. What remains is just bar. We never say differential pressure is 7 bar G. Then it is not gauge. It is not a differential. I'm sorry, it is not differential.
Understand, yeah.
We simply say 7 bar, or say millibar, or Pascal, or bar, or atmosphere, or millimeters of mercury, or millimeters of water. These are all the units for pressure. Even more, there are more. So,
Okay. And the pressure ratio is 2.4.
Aha, aha, aha. No, no, sorry. No. Please go back to the definition for the pressure ratio, please.
Oh, okay,
Go back
it's
to
need to be calculated with the absolute, okay.
Exactly. You know, this is this is extremely important. When you calculate it, you will see that it won't be 2.4, and that could be huge, let's say, effect or impact on the later calculations. No.
تشکر عمل کردن
خب حالا
خودشون بگن
فقط مطمئن که اینو بتونن پیداش کنن دیگه این توی ساکشن ابسولوت
این
مسئول
نتونست حساب کنه
Okay, ladies and gentlemen, just if I'm allowed to give you a little hint. Do you hear? Yeah, do you hear? Yeah, do
what
you hear
will be
me?
the one bar G is equal to how much 1 bar A?
Why do you need to know how much 1 bar G is? I mean,
Because I want to calculate the bar G 2 bar absolute, then we could have our right the pressure ratio.
okay, that is why Mr. Ranchbarian has given you the elevation from the sea level. The elevation, the altitude. You see, the elevation is 1,150 meters.
That's correct.
So what you need to know from the, let's say, from that, I think it was slide 4 or 5, was it? You know, that those graphs in blue and yellow. If you go over there, you can calculate. If you put the amounts in the boxes, you get the amount for the pressure at the site, at the elevation of 1,150 meters, and assume 15 degrees centigrade, 0 degrees centigrade. What it is there? It is not that important at the moment. Okay, can you see this? screen now?
Yeah, we can.
Okay. This is, you know, please, yeah. من از اینکه حتی شما عددش هم جا نوشتین که عددش رو پاک کنیم. نباید ببینن اصلا.
In case the pressure at the sea level will be remain 101325.
Yes.
And in case the temperature 15 degrees centigrade, the altitude
Yes.
1150 meter, the air pressure at altitude will be 8251.35.
Let me check it with Mr. Alexander. One moment, please. Yeah, exactly, exactly. Other ladies and gentlemen, is it clear to you how to calculate the air pressure at that altitude, 1,150 meters? Are you seeing the screen now? Can you see the screen?
Yes, we
can.
see the screen, but so as soon as Sayed already got the right answer, just because Anatoly has joined us, can you please step by step do the algorithm, like just can you tell us orally what you did after what in order to reach that value, if that's okay with you, Sayed? Thanks.
If you mean this screen that we have shared, you know, here in the right part of that, in the blue part, at the top, it reads pressure at sea level, which is, it is given in Pascal. Pascal is a very, very, very small value. I mean, therefore, the figure for that will be very high. Unfortunately, it doesn't have it in kilopascal. Okay, leave it. At 15 degrees centigrade, okay. Here we put altitude 1150 meters. Is it readable now?
Yes, yes.
It is.
And then we click calculate. So the figure, I don't know if you can read it. It reads 88251.35. This is Pascal. Pascal is a very, very small amount. So we had better express it in kilopascal. So sorry. So if we divide it by 1,000, it's gonna be kilopascal. So it will be 88.251 kilopascal. All right. شما به بحث بار بدید. حالا ولی اینجا این چیتون متاسفانه نداره مهندس این کلکولیتر بار، این فقط چیزو داره. میدونم حالا میخوام چه اینو دارن چیز میکنن، اینو دارن. من ما اصلا برای همین بار دادم. اگر میتونستم بپرسم که خودشون برن میخوام برام بیارم. نه حالا من بهشون میگم. نه نگاه کن اینجا نشون میشه. Please see that.
You can easily convert pressure in a unit of Pascal to unit of the bar.
If you remember, we reached the value 88251 Pascal. As you see, the figure is very big, but the amount is really very low because the Pascal is a very, you see, small value. Now, in this conversion, which is available, and I can give you a very quick formula for calculation. If you put it here, Pascal has been converted to bar. 88251 Pascal is 0.88251 bar. Okay, so this is the pressure at 15 degrees centigrade at that elevation, 1,150 meters. All right. Is it clear so far?
Yes, it is clear.
Everybody, any questions over there? Please.
For now, it's good for me.
All right. All right. Now, so we. Okay. Now, all right. Knowing this value, now please reply to the question, to the problem. How much is the pressure ratio? Differential pressures, okay, say it correctly, calculated that this is 12 minus 5, which is 7 bar. And we never say 7 bar G or 7 bar A when it is the matter of differential. Okay, we never say that much bar gauge or that much bar absolute, never. It is just bar, right? Now, what about the pressure ratio? I want you please give us the amount for the pressure ratio, knowing the atmospheric pressure that you can now see on this screen. And it is in bar absolute, always. Always it is in bar absolute.
اینو کردی اگه میرم جلو بخوام سر فلو ادامه بدیم که فلو یعنی دما رو من میگم و اوکی میکنم و بعد معادل حالت رو بزنیم چون نمیگیرم من به نظرم همین اینو بگیرم بسید بگیرن و اوکی باشه خودش نه میخوام این داره نمایی که باشه من داره 4 مثلا من بچه دارم میخوام اصلا تمامش کنم ولی بیمستان نمیدونم نه برای فلو بودن سر کامپرسیبیلیتی و اینا رو میگیم من خواهم کانورت فلو یه کامپرسیبیلیتی هم بدم و فلو کامپرسیبیلیتی فلو منظورتون چیه؟ مثلا اشوال فلوش یا حداقل من الان دما و فلو هم توضیح میدم ولی کانورتش بذاریم معادل حالت اینا رو بذاریم اول.
Is that 1.0069?
What are you talking about? Go ahead. Say it again.
I try to calculate for the pressure ratio.
Okay, good.
The pressure ratio is around 1.0069.
No. Say it again. Pressure ratio is the ratio of discharge pressure divided by suction pressure, both in absolute amount.
Yeah.
You have the suction and discharge engaged. So first of all, you need to change it to convert it to absolute. And we discussed, I think it was on probably on slide 3 or 4. You know, for P absolute, you should actually add atmospheric pressure at the site to the gauge pressure that you already have.
So normally we add 1000 to with the gauge pressure in order to take the absolute pressure.
Oh, again, look, say it, that is correct if you're at the seashore. But in this example, you are not at the seashore. You are at the elevation of 1,150 meters above sea level. So the atmospheric pressure changes. You are not at least, you are not, you know, at your town. You have gone to the mountains. Are there any mountains close to you?
So it means it will be going to add the additional, the altitude height. Am I right or not?
No. From the altitude that you have, you should find the amount of air pressure at that altitude. You see, altitude is 1,150 meters. Am I correct?
That's correct.
All right. Now go to that page that Mr. Rajbarian showed regarding calculation of the atmospheric pressure over there. Yeah, here. You see this page right now?
1150.
Yeah, 1150 is the altitude. Okay, calculate the air pressure over there on the blue table.
82.5.
Exactly. What is the unit for that figure?
It's a Pascal.
It is Pascal, but we want it in bar, so we have to divide it by how much?
0.08825.
Exactly, it's gonna be 0.8825 bar. Bar what? Bar absolute, because this is actually atmospheric pressure, but barometric pressure, and barometric pressure is always in absolute, all right?
Right.
So far so good.
Okay.
So now you have to add this to what?
Need to add this amount.
Sorry, so we converted to the air pressure at altitude to bar, correct? So it's 0.88251, correct?
Yes, it's correct.
So,
Yes.
I'm sorry, I couldn't understand. What should we do now?
Okay, let's solve it together. At the first step, we have elevation from the sea level is 1150 meter. Okay.
Yes.
With this side, you can calculate the barometric pressure at this elevation. It's equal to 0.8825 absolute bar. Okay, is it clear for you?
Yes, okay.
Okay. After that, we must calculate the suction pressure at the entrance, suction pressure of the compressor, and the discharge pressure at the outlet of the compressor in terms of the absolute pressure. Okay. We have the 5 bar G at the suction pressure. See this formula? Gauge pressure is equal to absolute pressure minus atmospheric pressure. Okay. Did you understand?
Yes, okay.
Okay, you can calculate absolute pressure is that gauge pressure plus atmospheric or barometric pressure. Okay. See here, we have the 5G. Yeah. Can you see that?
Yeah, we can see.
Okay, absolute pressure is equal gauge pressure plus atmospheric pressure. You did calculate absolute atmospheric pressure is equal 0.8825. And you have suction pressure and discharge pressure at the term of the gauge pressure. You can plus these two terms to calculate suction pressure and discharge pressure in the absolute term. See here, 5 plus barometric or atmospheric pressure is suction pressure at the term of absolute. Can you see here clearly?
Absolute, yeah.
Okay. For a discharge, 12 plus barometric pressure 2 is equal to 12.8825 for absolute. Is it okay?
Yeah.
Okay. After that, you calculate the absolute pressure. You can calculate differential pressure and pressure ratio 2. For differential pressure, you can discharge pressure minus suction pressure. Okay? In the absolute term. In the absolute term, discharge pressure is 12.8825 minus suction pressure in absolute term 5.8825. It's equal to 7 as you calculate it. Okay, is it okay? Any question?
Clear.
Okay, for pressure ratio, you can divide discharge pressure to suction pressure in terms of the absolute pressure.
12.8825 divided by 5.8825.
Exactly.
Exactly.
So the result is 2.19.
Yeah.
You remember, Sayed, you told me first that the pressure ratio is 2.4, I'm sorry.
2.4, yeah.
And you know, you now see the difference.
Correct.
You know, the correct pressure ratio is 2.19, which is lower than 2.4, and this is important in the calculations. You know, in the next calculations for and design of the equipment.
Correct.
So is it clear to everybody? Any questions, please?
For me, it's clear.
Okay, Svetlana, Claudius, the other ladies.
Yes, thank you for more detailed step-by-step way. Thanks.
Please. Okay, now we continue with the presentation.
Okay, the next important parameter is the capacity and is the volumetric flow rate. Capacity, the capacity of the compressor is the rate of the flow, which is determined by delivered mass flow rate divided by inlet density. For an exhauster, it is determined by the inlet mass flow rate divided by inlet total density. For side stream machines, this definition must be applied to individual section. Okay, see this formula? At the left side, you can see mass flow rate. In the inquiries, the client must deliver this value to you. It's equal to volumetric flow or capacity multiple density. In the data sheet, you can see the density of the gas in a certain condition. Volumetric flow rate. The volumetric flow rate or volume flow rate of the volume flow is defined as the fluid volume passed per unit time through the fluid flowing bodies such as a pipe, channel, compressor, and other. Generally, the volume flow rate is denoted by the symbol Q. The SI unit of the volumetric flow is cubic meter per second. The cubic meter per hour is also used as a unit of the volume flow rate in the turbo machinery. Flow rate is also measured in cubic feet per second or CFM, cubic feet per minute in imperial system. Volumetric flow can be expressed with the flow formula. Q is equal to A multiple V. In this formula, A is a cross-sectional area of the pipe or a channel, for example, in the compressor, in unit a square meter. V is a normal component of the velocity in units meter per second. Normal component of the flow velocity is perpendicular to your cross section. We define the component of the velocity that perpendicular to cross section is normal component. Okay, any question? Is it clear for you?
Yeah, it's go on, please. And how is the important to understand the flow ratio while in the inquiry, please?
Because the design of the turbo machinery, one of the important parameters to design is the flow rate. At the next session, we discuss about the performance curve to evaluation of the behavior of the compressor of the fan blower. One of the important parameter is the volumetric flow. With the pressure ratio, and volumetric flow, you can select the right equipment. You can evaluate the behavior of that. You can assessment of the certified points such as rated point, normal point, cold mode point, and other things. You did see it many times in the inquiries.
Sayed, back to your question. Pressure ratio starts from 1. Actually the smallest value for the pressure ratio, which is almost does not exist, but we can assume is 1, which means discharge pressure is equal to suction pressure. So A divided by A is 1. And this, of course, in reality does not happen. Otherwise, you wouldn't need equipment to handle the gas or air. For actual fans and centrifugal blowers, I would like to name it centrifugal radial blower. This ratio is still very low. It is something between in the least value, in the smallest value, it is 1.01 and goes up to 1.2. Of course, it can be even higher, let's say up to 1.3. In that case, your blower, your centrifugal blower or centrifugal fan is not in single stage. It has to be in more than one stage, sometimes in 2 stages and even higher. But above 1.3, it is not called blower. It is not called fan. When the pressure ratio is higher than 1.3, we have to use compressor. Then you may ask, okay, up to what figure this can go up? I would reply, so very high, very high. Let's say 1.5, 2, 2.5, 4, 5, 6, 8, 10, 12, 15, 20, 50, 50. Pressure ratio can be very high, and that specifies the type of equipment that you have to select. For instance, if the pressure ratio is 50, you can never use, never can use, let's say, centrifugal blower or fan, not even probably centrifugal compressor. You have to use reciprocating compressors. Reciprocating compressors are not centrifugal machines. Those are called positive displacement machines, and they are abbreviated to PD. P for positive, D for displacement. For positive displacement machines, I would say mainly reciprocating compressors, it can be very high, 20, 30, 50. This is the pressure ratio. But for fans and blowers, centrifugal blowers, just suppose that that's a low intake. You're familiar with low intake job. It's a centrifugal radial blower. I don't recall at the moment the amount of pressure ratio, but I think it would be something about 1.18, 1.20, something around that. I don't recall that at the moment. And that is why we actually selected centrifugal blower, and this is of course as per their requirement also, the client's requirement, because they mention API 673, which is the applicable standard for centrifugal blowers, fans. If this is clear, I would like to mention something about the flow rate. Do you have any question at the moment regarding your question, Sayed?
Basically, what I was trying to understand, in addition to that question, and imagine like there will be information received from our client with the differential pressure or the pressure ratio is more than like 2 bar, imagine. Yes. And they keep asking us to maintain a centrifugal blower. So what will be the challenge for us in order to meet the requirement or to convince this is not belongs to the blower, but it will be going to the IGB type of compressor?
It has to go to compressor. When the pressure ratio, let's say, is 2.1, 2.2, even less, 1.7, it is almost not only impossible for us, but impossible for the industry to go with blowers, API 6.7 blowers. It is impossible. So we here go with the IGC, integrally geared compressors, all right? Integrally geared compressors, and which is a centrifugal compressor, of course, or some other companies which manufacture single shaft centrifugal compressor, they can also make it with that pressure ratio of let's say 1.8 to 2.4 and higher. The other possibility which can introduce, but we don't know if they accept it or not, is instead of centrifugal machine, we move to positive displacement. Let's say if the pressure ratio is 2.5, it is very simple for us. And if the flow rate is not very low, when the flow rate is very low, everybody will have problem. But if the flow rate is not very low, and by very low I mean something about 2,000 or 3,000 cubic meters per hour at the inlet to the compressor, if the pressure ratio is 2.5, let's say, one can easily introduce and code for so-called rotary blower. Please make a note of this word, rotary blower. Rotary blower is not a centrifugal machine. It is a positive displacement machine that we do not manufacture, do not design, but we can code, we can outsource from the sources that we know. So did I answer your questions here?
Yeah, thank you. That is what I want to learn and understand. Thank you.
Okay. Regarding flow rate, as I go very quickly because Mr. Ranjbarian has so many other things to tell you. Remember, there are two types of flow rates given in the data sheets. Some clients give it in volume flow rate, volume, and the amount is given in cubic meters per second or cubic meters per hour or cubic feet per hour, so on and so forth. This is the volume. The other type for the flow rate that might be given in the data sheet is mass flow rate. Mass flow rate. Mass flow rate means the amount of mass, not volume. Mass flow rate is always given in kilogram per hour, not cubic meters per hour, kilograms per hour, or pound per minute, pound per hour, pound per second, or grams per, let's say, second. These are all masses, not volumes. And remember, in a compression scenario, in a compression process, what always remains constant always remains constant, no matter what you are doing with that flow, with that gas or air. What remains always constant is mass flow rate. Volume flow rate changes. Why? Because when you compress a gas or air, the volume decreases. That's simple. But the amount of mass never changes. That is why I personally sometimes like to work with mass flow rate and not volume flow rate, because when we are, okay, Mr. Brian will explain to you later. When we are talking about volume flow rate, we have 3 different volume flow rates. One is called normal volume flow rate. The second is standard volume flow rate. The third one is actual flow rate. And these are different even for a specified process. The amount of flow rate at normal conditions, but this amount of flow rate at the normal conditions meet at sea level and 0 degrees centigrade. This amount of flow rate does not remain constant when you consider that flow at a different temperature and a different altitude, elevation. Just for your information, standard flow rate is defined as the flow rate at sea level, but at 20 degrees centigrade. In Russia and CIS countries, they say 20 degrees centigrade. Many places, other places in the world, they say at 15 degrees centigrade. The difference is not really that much anyway. Okay.
Okay, thank you.
Okay, I'm sorry. I was Mr. Zidbergen was recalling me that I was talking too much. Okay, his sister. It is sister now.
No, you are not talking. Actually, you are teaching us. So in teaching, so we are happy to listen and extra things also.
Definitely.
I'm
Definitely.
unfortunately talkative, too much talkative, and this can be boring. All right.
This is not really boring. Again, we are happy to hearing from you with a lot of knowledge, additional, and we are all happy here.
Okay, please. Okay, please go ahead.
Okay, next parameter is temperature. One of the most important parameters for selecting and evaluation of a turbomachinery performance is the temperature. Temperature is generally described in degree of centigrade in SI units and degree of Fahrenheit in imperial system. In many cases, for example, changing volumetric flow, we must use absolute thermodynamically temperature or absolute zero scale. For SI system, it's Kelvin scale that is equal to minus 273.15 degree of centigrade. And for imperial system, it's in degree of Rankine scale. For converting temperature from degree of centigrade to Kelvin, we use a blue formula. Temperature in degree of centigrade plus 273.15 is equal to temperature in Kelvin scale. Is it okay?
Yeah, it is okay. Thank you.
Okay. For converting degree of the Fahrenheit to degree of the Rankine, we can use a blue formula. Degree of Rankine is equal to degree of Fahrenheit plus 459.67. Okay, Mr. Sadri did speak about the flow converting, normal flow and standard flow. Now we want to speak about it. Flow converting. In many inquiries, volumetric flow rate may be described in different terms, such as normal flow rate or standard flow rate, and we must convert it to actual volumetric flow rate or vice versa. Before describing converting method, we must have a good understanding about a state equation for ideal gas. Anyone can define for us ideal gas?
In case you are tired and you want to have some rest and refreshment, you please tell us.
No. Okay, let's go. Ideal gas is a theoretical gas composed of many randomly moving point particles that are not subject to interparticle interaction, and its behavior can be described with a state equation or perfect gas law. It's an important equation for us. We can describe perfect or ideal gas law with this equation. P multiple V is equal to M multiple R multiple T. In this equation, P is absolute pressure, V is total volume, T is absolute temperature, R is the universal gas constant, M is the number of the mole multiple molecular weight or mass of the gas. We can write perfect gas law with new form. PV divided to T is equal MR. Right side of this equation is a constant, and therefore we can compare two different states of the gas with each other. For example, P divided by T in state 1 is equal to PV divided to T in state 2. For use this equation for converting flow together, we must derive both sides to time. We can use this blue equation for converting the state of the flow. Q1 is equal to Q2 multiple pressure ratio, multiple temperature ratio, multiple to compressibility ratio. About the compressibility, we will discuss completely at the next session. Q is equal to total volume divided to time or capacity. V is the volume in unit of the cubic meter. T is the time in the second unit. Compressibility unit is a dimensionless parameter. Compressibility factor or compressibility usually defined as Z is equal to P multiple V divided to RT. Is a unity for an ideal gas. It should not be confused with the isothermal compressibility coefficient. In the mass engineering work, the compressibility factor is used as a correction factor to ideal gas behavior. It's a parameter, dimensionless parameter to define a real gas to ideal gas behavior. We will discuss about it completely at next session.
Let me just add this point to this matter of let's say perfect gas law, that this compressibility factor Z is normally given in the data sheet by the client. Okay, Z factor, compressibility factor is given by the client in the data sheet. And that figure, that Z, is almost always very close to 1, very close. Just a little bit above 1 or little bit below 1. And this is deviation from the perfect gas law, because perfect gas is something really perfect and not very realistic. In reality, the gases that we are dealing with are not 100% perfect, and we cannot actually refer to that formula PV equal to MRT unless we put Z before M. So it should read PV is equal to Z times MRT. Now, you see the screen, don't you?
Yes, we can see right now.
Okay. Yeah. Now at the bottom of this page, you see from this this formula, we divided the both sides by T, so we got this formula: PV over T is equal to MR. This is more, let's say, easy to use the formula. Almost this is very the same as the first one. The reason is that both M and R are constant. M and R, M is mass, and I told you that M always remains constant. R is also constant. It is actually universal gas constant. It is always, specified value. So PV over T is always constant. That is why this is very useful and important formula for different cases of a gas. Different cases, I mean, at different pressure and different temperatures. The only other point that Mr. Ransberry also mentioned is that please remember, P must always be absolute, never engage, never. It has to be, it must be always in absolute amount. And T is Kelvin. This is Kelvin, this is not centigrade. How do we get to Kelvin? We just add 273 to the centigrade temperature. For instance, if the temperature that we are talking about is 23 degrees centigrade plus 273, it's gonna be 300 degree Kelvins. So T is absolute temperature and P is absolute pressure.
Sorry, Mr. Sadri.
Please.
So in the first equation, you said that it should be a Z before M, correct?
Yes, in general.
So what does this Z means?
Oh, the Z. Okay. As I tell you, that letter Z is compressibility factor, and it shows the amount of deviation from the perfect law, from the perfect gas law. This is the figure for the perfect gas. This equilibrium. But in reality, not for many, there are gases which are really close to PV equal to MRT, very close to perfect gas, all right? But in reality, and because of at different temperatures and different pressures, this equation is correct if you put a Z in front of M, so that it reads PV is equal to ZMRT. Z is called compressibility factor, but it is still close to 1. It is not exactly 1. It is close to 1. And this amount of Z either given, or you can go and find it, you know, in the books, in the reference books, in the, let's say, handbooks, in the web, everywhere. Yes.
Can we have this absolute in the perfect gas form too? If we can have the Z in the form down, in the down.
Oh, yes, of course. Yes, of course. That is the same formula. Yes, of course.
Okay.
That is the same. Actually, it should read PV over T is equal to ZMR.
Okay.
That is the same. That is the same question. Exactly the same question.
Okay. Thank you.
Please. Yeah.
Okay. You can use this site to calculate the compressibility too.
Yeah, there is you can see that link for the compressibility factor that given in the. Can you see this?
Yes. We cannot see the screen. We see the PowerPoint, not your screen. Yes, now we can see. Now we can see.
Okay. This address has been given in the presentation. If you go to this link, you know, for calculation of Z, you actually use it by giving the, you know, pressure, volume, and number of moles, gas constant, this sort of, and temperature. Again, remember that temperature is K. This is Kelvin, not centigrade, okay? And that pressure over there is absolute in the first line. All right?
Okay. State 1 is actual condition and state 2 is a normal condition. You can define normal condition per many standards. For example, normal condition in API STD is equal to temperature is 0 degree of centigrade and the pressure is 1 atmosphere. In the ISA and ECO standards, normal condition is standard condition is 15 degree of centigrade and 1 atmosphere for pressure, and standard condition for EPA is temperature is 20 degree of centigrade and pressure is 1 atmosphere.
This is the standard conditions actually used by Russian and, you know, Tajikistan and Uzbekistan and CIS countries. This is the standard. This is the way they define or specify standard condition. But in the rest of the world, it is as 15 degrees centigrade and not 20. The pressure is the same. It is the pressure at the seaside, at the sea level. All right.
Okay, at the next session, we're converting a flow rate to a normal flow rate example to actual flow rate. At the next section, you can see atmospheric pressure that change with elevation in this diagram. The degree of the air temperature is 0 degree of the centigrade.
This is a very, if you see the screen, this is a very simple and useful let's say curve for calculating or reaching atmospheric pressure at different elevations. But remember, this is important. This curve is valid when the temperature of the air is 0 degrees centigrade. Then no matter when the air is, whether it is at sea level or it is in the mountains, from the horizontal axis, you see, if you go through the horizontal axis at different elevations from sea level, the atmospheric pressure is different. And again, you see from the curve that when the elevation increases, the atmospheric pressure decreases. Okay, that is why when you go to, let's say, Mount Everest, you don't have enough air to breathe, and you have to use oxygen cylinder because the air very lean over there. Is not rich. Atmospheric pressure is very low in the mountains, and if you go very high to the mountains, you cannot breathe. There is not enough oxygen over there. On the other hand, when you go to the sea level, well, it's the best with respect to the amount of oxygen in the air, or generally the air itself. All right.
Okay, at the next region, you can see the change of the density to the air pressure and different ambient temperature. A colorful line is the temperature, and the horizontal axis is the air pressure in unit of the kilopascal, and the vertical axis is the density in kilogram per cubic meter. You can see the change of the density in the many different temperature and in the many different air pressure.
In this is air pressure and
Density.
okay,
at the next section, you can see change air density with the gauge pressure in the unit of bar. Horizontal axis is the gauge pressure, and the vertical axis is the density of the air in unit of the kilogram per cubic meter. But it's a mistake here because gauge pressure can show with the bar without any suffix at this location. You can see many.
Sorry, where is the mistake? I couldn't understand.
Gauge pressure
inside the parentheses after bar you should put G, which tells you
okay
gauge in the parentheses. Okay.
Yeah. Yes, and at the same of previous diagram, the colorful line show the different temperature.
Okay, is it?
Okay, thank you so much. It's finished.
That was the last slide actually on this presentation. And
thank you for the presentation.
Please, if you later go to this presentation and find any query or question, let us know. All right, just let us know and ask.
But you will send this presentation, correct? We will have it.
I'm sorry.
We already have it, Svetlana. We already have
okay,
it.
good.
After this, I will upload the presentation and the recording of the training session in our server, so everyone can see it. And if we have any doubts or something, we will ask and get in contact with Mr. Sadri.
All right. You can also, if you like, contact on WhatsApp with Mr. Ranjbarian. I will give you his phone number. He wanted me actually to.
Yes, please. We will add him at the group. It will be better, I think.
Yeah. Yeah. All right. Oh, okay.
Okay, thank you so much for the presentation and explanation. It was very interesting.
You're welcome. We welcome your queries and questions or any comments. If something is wrong with the way that we present, by we, I mean myself, So I would be thankful to receive your comments to tell me, okay, you are not good here and you can do this or can do that. I'm actually receptive of your comments, all right?
Okay, thank you very much for this presentation today, the second training. And we will be going to discuss further, like when we could have the next training, and whatsoever the date and the time we will be agreed accordingly, we will be announced. A part of that, when this presentation will fully close and the recording will be closed also, I need a small minutes with Mr. Sazi for the day-to-day discussion things.
Okay, okay, you want to discuss with something with me, Sayed?
Yeah, this is some related to our ongoing inquiries and information, because we had some kind of a discussion in-house with the presence of Mr. Sazad when he was here. So there are some